Hello students. We are moving on to the next section in our chapter 4. This is 4.4, which is unit rates. This is one of the more useful life applications of math where you can use it in your daily lives or maybe not now, maybe if you're not shopping as much, but as soon as you start shopping, you will have to do some comparisons between prices and hopefully trying to make a better deal. And this is going to come in very useful. So if you look at your note 4.4 on page 146, so it's talking about the unit rates, and I'm just going to highlight. It says that the unit rate, here we go, unit rate is a rate in which the second term is 1. That sounds not so clear. So to simplify it, really it just means that oftentimes we are given rates um, where it's not a price or it's not speed or the amount for just one unit. In the example that they state here, they say that if you earn $4, sorry, if you earn $50 for 4 hours, what this is a rate that tells us that you're earning $50 for 4 hours, not for 1 hour. So it's not really that practical in terms of what you're looking at because yes, $50 for 4 hours, that seems like a lot of money, but what is it really uh, for 1 hour of work? So that's why it's very useful to always calculate this unit rate, which would be the salary that you would receive for 1 hour of work. Or if you're purchasing something at a grocery store, a lot of time advertising will be saying that a package of 12 costs a certain amount of money, but it would be useful to know how much does one item in that package cost, just for the sake of comparison. So that's what a unit rate really is. So in this example, they say if you're earning $50 for 4 hours, your earnings can be expressed as a rate of $50 per 4 hours. If we are using equivalent fractions, or in this case, equivalent unit rates, you can calculate that it's actually $12.50 for 1 hour. How do we do that? Well, we set up a proportion. So you can see in here, you have a rate of $50 for 4 hours, and then you're going to set up 1 hour on the other side because we're looking for unit rate, and you will use a scale factor to calculate what the missing value is. In this case, it's 1250. And that's really can be seen actually at the bottom here. Um, and if you don't remember how we calculate that, I will just do it here quickly on the side. Um, we cross multiply, so we cross multiply this way. So 4 hours times x is 4x, and 1 hour times 50 dollars is just 50, and then we divide both sides by 4, and that turns out to be 1250. So that's how we solve all these proportions. The most important thing is setting up the portion initially, and then we solve it like we would any equation. Um, so we're going to go straight into the example. You can see kind of how useful this is. There's some examples here, but sorry, we're going to go to practice questions, which is on the next page. So here we go. It says question 1, determine each unit rate. So we have 12 kilometers walked in 3 hours. 12 kilometers seems a lot, but it's over 3 hours. So really to get a sense of how long this really is, we're going to try and find out how much you walked for 1 hour. So we set up a proportion of 12 kilometers for 3 hours, and we make it equivalent to unit ratio of 1 hour. So we're going to put it at 1 hour down here just to make sure. And we're looking for the missing value for the distance, how much we traveled or walked in 1 hour. So we cross multiply. So 3 times x is going to be 3x. I'm just going to the side here, equals 1 times 12 is going to be 12. And the last step is we divide by 3, which in this case, I guess I'll actually write it out here so I have more space. X is equal to 4. So it seems like the unit rate in this case is that you walk 4 kilometers for every hour. And that's how most of these questions are going to be set up. So the next question would be the apple question. It says that 10 apples, in this case, cost $4.50. You want to figure out maybe how much one apple would cost. So again, we set up the same proportion, $4.50 for 10 apples. If we want to find out how much one apple is, we will fill this out as 1, and we are looking for the missing numerator in this equivalent rate. So cross multiplication again, it's going to be 10 times x and 1 times 4.5. If you really look at it, we don't really have to cross multiply here because on this side we have x divided by 1 really is just x. So really what we have to calculate is just 4.5 divided by 10. And that's it, nothing else, because yes, we can cross multiply, but this is going to save us a little bit of time. So 4.5 or 450 divided by 10, if you punch it on your calculator, it'll just, I'll write it over here, x is equal 0.45. What does that really mean? Well, it means that one apple will cost 45 cents. So that is the unit rate for one apple, 1 unit of measurement in this case, which is one apple. Then we have C is $34 for 4 movie tickets. So we want to figure out actually how much does it cost for 1 movie ticket, and we would set up again unit proportions. So we have $34 for 4 tickets, and then because we're trying to figure out how much 1 ticket is, we keep it also in the denominator. We put 1 in the denominator, and we're looking for that missing cost of 1 ticket. So I'm going to show you the other way that we shall solve proportions with a scale factor. If we're going to 4 into 1, means where we're dividing by 4. And then in order for this to be equivalent to the original rate, we're going to divide by 4 on the top as well. So if we have 34 divided by 4, if you punch it in the calculator, you get that x is equal to 8.5. Now, what does that mean to our question? That means actually that 1 ticket will cost $8.50. And that's what all of this unit rate is. Let's see. On our next question, we have 80 megabytes of data downloaded in 4 minutes. So this might be like an internet speed. And if it was told or described to you like this, 80 megabytes of data downloaded in 4 minutes, you wouldn't really know if this is fast or slow. So you really want to find out how much it is for 1 minute or maybe 1 second or whatever it is. So in this case, we're just going to find what 1 minute is. And again, we're going to set it up just like we did before, 80 over 4. And because we're looking at unit rate, this is going to be our 1 minute. And we're missing for the missing variable here. I'm not going to cross multiply again. If you remember, the easiest one was just to divide 80 divided by 4. And so in this case, x is going to be 20. So that means our downloading speed is 20 megabytes per minute. So that's really what we're looking at here. So this is the next example is kind of more better life application in terms of, let's say, buying groceries or purchasing gas or something like that. And you want to find out how much does it actually cost for maybe a pound or liter or kilogram of your product. So if you ever go to Flyers to shop, you will have to be able to do something like this because then you're able to compare the prices between different stores. So you can't just look at the overall price that's advertised because a lot of times they don't advertise the same amount. So you have to find what the unit price is for each one of these items and then you'll be able to compare them. We are going to see that actually better in question 3, but question 2 will kind of lead us into it. So in A, we have $26.91 for 9 kilograms of ground beef. We want to find out which one of these unit rates in column 2 corresponds to the ground beef. So if I just set up another one of these unit proportions, 26, oops, my pen is not working well, 26.91 over 9 kilograms, and I'm looking for 1 kilogram. So remember, if I just divide 26.91 divided by 9, I get 2.99. So it seems like, I guess I'll write it here. Actually, I'll just connect it right away. X is this one. So that means that ground beef is double I. There we go. Similarly, if I want to do uh, the roast, it seems like 31.96. So I'm going to write it in a different way. I'm going to write it as X equals 31.96 divided by 4. And remember, this is unit rate, so it's over 1. But really, we're just dividing 31.96 by 4. 31.96 divided by 4. Which is 7.99 apparently. So that one goes here, 7.99, and that means that roast is 4. There we go. Gas. So in this case, you actually, if you ever fill up a car with gas, you want to know if you're getting a decent deal. And 61.50 for 50 liters of gas, it's you're not sure until you actually calculate how much 1 liter of gas is. And you'll see that at the gas stations. Usually that's how it's advertised. So we would set up another proportion like that. 61.50 over 50 liters. And we want to find out how much 1 liter is. All I'm going to do is just divide 61.50 6150 divided by 50. And I have 1.23. So this one is up here, which means that the gas is just I. And then juice, we would do the same thing. You can just go and divide 4.98 divided by 2, and that should be 2.49. That's the only one that's left. So I'm not even going to write it. If you want to check it, just set it up and just do the same calculation. The next question. So this is really where it matters when you go to shop. So this is the kind of decisions you will have to make, and these are the kind of calculations you should make because it will save you money. So what you have in each one of these questions is you have two options, and you have to decide which one is actually a better buy. So in the first one, we have water. We have 12 bottles and we have 24 bottles, and then we have prices for each one. So $2.99 for 12, $4.99 for 24. So if I want to find out how much one bottle is, I'm going to do it through a shortcut. So remember, usually we would set up 2.99 over 12 equals x over 1. And then we would calculate it. But I can, our essential calculation will be 2.99 divided by 12. Divided by 12, which is 0.25. So I will say 0.25 is my unit price. So one bottle in this pack would cost 25 cents. If I do the same thing on the other side, all I'm going to do is divide 4.99 divided by 24. And that will give me 24, there we go. That will give me how much one bottle is. So in this case, 0.21. So one pack is 25 cents per bottle. The other one is 21 cents per bottle. So which one would I buy? Well, if I want to save some money, I would buy this one. That is a better deal, a better buy. Again, depends what you're looking for. Maybe you don't need 24 bottles, so you will buy 12 bottles. But this would be a better deal if you are shopping for water. The next one is we have shrimp. So we have 2 kilogram packet and we have 1.5 kilogram packet. Same strategy. I will divide 18 by 2. So $18 divided by 2 kilograms. What this will give me is how much does it cost for 1 kilogram of shrimp. So if I divide 18 by 2, you will hopefully know by now this is $9. So that means that 1 kilogram of shrimp in this case will be $9. If I do a similar calculation on the other side, 1520 divided by 1.5 divided by 1.5, I have 1013. There we go. So in this case, it cost me $10.13 for 1 kilogram of shrimp. So it seems like B, in this case, it's actually better if you buy the 2 kilogram pack. Much better. Then we have jelly beans. So you have a pack of 100 jelly beans and you have a pack of 500 jelly beans. So if I want to find out how much one jelly bean is, I will do the same calculation. So in this case, I will do 1.99 divided by 100 jelly beans. I get a price. It's a very weird number. So it's this 0.0199. What does that really mean? So remember, this is money. We're going to round it actually to this second decimal place. So it's going to be actually 0.02. So that means each jelly bean, in this case, will be 2 cents. That's pretty cheap. Now let's look at the other one. 8.99 divided by 500 jelly beans. Let's see what that gives us. Divided by 500. This one is 0.01798. All right, if I round this one, it should be, I'll write it here, there we go, 0.02. Wait a minute, so they essentially both cost the same? Yes, if we round it, but if we look at all the digits, we will notice that this bigger bag is slightly cheaper. Not by much, but it is slightly cheaper. So in this case, yes, I would circle the $8.99 bag, but maybe I don't want 500 jelly beans, so I will buy 100 jelly beans, pay $2, and get your sugar fix. So it depends. In some cases, you have bigger savings. In this case, not so much. Next one, we have iced tea. Again, two sizes. One is 500 milliliters, one is 750. Same process. But as you can see, when you get to these smaller units, such as jelly beans or milliliters, you're going to see that you're going to have to look at more decimal places to make a better comparison. So in this case, I'm dividing 0.79 by 500. So 0.79 divided by 500. Okay, so this one is 0.00158. So this is less than 1 cent. So yes, we can round things, but we're going to have to look at pretty much all the decimals, as many decimals as we can to make a comparison. So in the other one, 1.89 divided by 750, also going to be a really small number. 750 is 0.00252. All right, so in this case, we actually see that the smaller size is actually cheaper. So yeah, sometimes people think that if it's a bigger packaging, if it's a bigger case or a bigger bottle or whatever, it's a better deal. But in a lot of cases, it's not. So you should do some of these comparisons to save some money. All right, next page. All right, we have Jess and Alice are meeting to play golf. Jess drove 15 kilometers to the golf course in 12 minutes. Alice drove 20 kilometers to the course in 15 minutes. Who drove faster? A faster unit rate. So in order for us to compare these two people, Jess and Alice, we can compare them with the information that's given to us. One is going 15 kilometers in 12 minutes, the other one 20 kilometers in 15 minutes. we have to find a unit rate. So in this case, we're going to find out how much they both cover in 1 minute. And then we're going to see which one's faster. So calculation. Here is Jess. She's doing 15 kilometers, 12 minutes. I'm looking for one. And then Alice, same setup. She's doing 20 kilometers in 15 minutes, and I want to find out how much it is for 1 minute. And you can see, I'll repeat this again. This is kilometers up top over minutes at the bottom. So I have to keep all my minutes in the denominator, all my kilometers in the numerators. Just to kind of remind you, I'll erase that just so we have more space to write. All right, here we go. So we can cross multiply, or we can just simply divide 15 divided by 12. So in this case, 15 divided by 12 is, in this case, I will write that x is 1.25. So that means Jess covers 1.25 kilometers in 1 minute, and Alice, we're just going to divide 20 by 15, and we will see that in this case, Alice is 1.33 kilometers. So the question is, who drove at a faster unit rate? Well, it looks like it was Alice. She covered more kilometers in 1 minute. It says, write each unit rate in part A in kilometers per hour. All right, so this is where it's kind of called unit conversion. So what we have here, I'll just use the example for Jess. We have 1.25 kilometers for 1 minute. There we go. And we are going to convert it into kilometers per hour. So that means on the other side, we have kilometers per hour. So we're converting from 1 minute to 1 hour, but we can't just jump from 1 minute to 1 hour. We're going to jump from minutes to minutes. And then we have to ask ourselves, okay, in an hour, how many minutes do we have? So in this case, there are 60 minutes. And that's going to be our conversion. So we're going from 1 minute to 60 minutes, which is times 60. And we're going to do the same thing on top. 60, so 1.25 times 60 is 75. There we go. So yes, we kind of did the conversion from 1 minute to 60 minutes, but really we are doing from 1 minute to 1 hour because that is the conversion rate from minutes to hours. So that means that, what's her name? Jess is going 75 kilometers per hour, which is pretty fast. And then if we do the same calculation for Alice, she's doing 1.33 for 1 minute, and we're converting into 60 minutes. So again, it's times 60. It's the same conversion rate times. So 1.33 times 60 is 79.8 kilometers per hour. So that's how fast she's moving. She was moving as she was driving to the golf course. All right, next one. Craig is shopping online for music files. Website A charges $32 for 35 songs. Website B charges 48 for 45 songs. Again, if we want to compare it, if we want to find this better deal that it's asking in question A, we have to find out how much it is for one song. So here is website A and website B. So website A is $32, 35 songs. I want to find out how much it is for one song. Website B is $48 for 45 songs. How much is one song there? Again, we can cross multiply, or I will just divide 32 by 35. I get that X is 0.91, so 91 cents per song. And in the other one, I'm going to divide 48 by 45. 45, 1.06, so 1.0, I will round it actually to 7. So $1.07 and 91 cents. So it seems like website A is better. So we're moving on to, I'll just put a little check mark It's a better deal. How much will Craig save per song if he buys from the more economical website? So we're comparing $1.07 and 91 cents. So we're going to see how much will he save. We're going to subtract $1.07 minus 91 cents, and it is 16 cents. There we go, per song. Is that a lot? Yeah, I think so. If you buy a decent amount of music, 16 cents can add up. Um, so, yeah, even if the savings is a little bit, it's better to save than to waste the money. All right, next question. At a grocery store, containers of juice is sold in three sizes. So this is like one of those questions I was um, talking about when you're shopping. You look at the grocery flyers, and you have all these same juices, but because it's different packaging, different quantity, you can't really compare them until you find a unit rate. So in this case, it says which size is the best buy. Justify your choice. We have small, medium, and large. 450 milliliters, 600, 900, and then the prices for each one. We're looking for unit rate. We are looking for dollars per milliliters. All we're going to do is divide. So if we have the cost to 50 for 450 milliliters, we're just going to divide 250 divided by 450. So unit rate in this case, and you will see the number is really, really small. So I'm going to write as much as I can. There, I'll round it off to that. And then I'm going to do the same thing. 350 divided by 600. There we go. That is 0.005833 and so on and so on. And the last one, 475. 75 divided by 900 is 0.005 2778, let's say. All right, so which one is the best buy? Um, I hope you can see that the large one is. They all have 0.005, and then the next digit is where they differ, and that next one is 2, 8, and 5, so it seems like the large one is the best deal. A lot of times students ask me, well, how many digits should I write down? Write as many as you can, and then you can kind of compare them once you see where they start to differ, and that's how you can make a comparison. And it's only when you have these small units such as milliliters or grams or um, like little jelly beans, that sort of stuff. So other than that, usually the prices are going to be fairly obvious which one is a better deal. All right, on to next question. Last Tuesday, Sandra filled her car with gas. She needed 55 liters to fill her tank, and the cost was $70.95. Today, she filled up 58.56 and pumped 48 liters. On which day did she get a better buy? So maybe, I don't know if you're aware, but gas prices change pretty much not only daily, they change hourly almost. So it seems like she got a better deal on one of the days, and we want to find out which day it was. And how we're going to do that is we're going to see how much does 1 liter cost on those different days. So we're going to set up the same thing, $70.95 for 55 liters. I want to find out how much 1 liter is. And then, what is it, $58.56 for 48 liters. I want to find out how much 1 liter is. So, since I have room, I will write it out properly. I'm dividing 70, 95 divided by 55. It was $1.29 per liter. Ooh, that's pricey. The other one, 58.56 divided by 48. It's dollar 28, 20, no, $1.24. There we go. Also pricey, but obviously, it seems like $1.24 is the cheaper day by 5 cents, which again adds up. If it's 5 cents per liter, she does save a decent amount of money. So let's see. The next part is our EQA preparation questions, which is going to be your practice questions. There are 3 questions. Perfect. Hopefully you understood that this is pretty useful math that you can use in everyday life. It can save you a lot of money. I use this often when I shop and when I look at flyers and compare prices of items, and you can definitely save a lot of money. That is it for this lesson. We have one more left for this chapter, and then we're going to move on to some other things. Thank you. Bye.